So what we're going to do is we're going to look at a few different reactions and see if we can figure out what their products are. So here in this reaction, we're given two reactants, and we're asked to predict the product. And what we can see is that this is a non-metal reacting with an oxygen. So we could classify this reaction as either a synthesis, or if heat or light was given off, then we could also say it's a combustion reaction. So therefore, what we know is that hydrogen and oxygen will combine, and we know that hydrogen and oxygen, when they combine, they often will give us water. And so then we just have to go through and balance. And so if I put a 2 there and a 2 there, that'll allow me to balance. So here I'm given two compounds. And so if we look at this, when we have reactions with two compounds, we can either have a synthesis or we can have a double displacement based on the categories that we're told. Well, this does not fit into any of the types of synthesis that we were given, so therefore this suggests that it's a double displacement. So what I'm going to do is I'm just going to indicate my metals, or my cations, that I know are going to switch. Then what I'll do is I will just determine my formulas. So I know silver is going to combine with acetate, and they both have a valence of either +1 or -1. So therefore, I'll predict that one of my products is going to be silver acetate, and then sodium nitrate will be the other. So our first step is we predict our products. Our second step is we balance. And so I can see here I have one of everything, so I'm good. My third step will be to now add states. And so we know that anything with group 1 will be aqueous, or anything with nitrate will be aqueous. So we can easily determine the state of this product. So now what we're going to do is we're going to go to our solubility table, and this one is just a little bit different than what we've used before. But we find acetate, we find the category that silver is in, we read across, and we see that has low solubility. So that tells us that this will be a solid. And so in this case, we know that in this reaction, what I get is I get a precipitate forming. And I would see this. So this would be a double displacement reaction that produces a product. Okay, so here I have an element plus a compound. Element plus a compound suggests that a single displacement reaction will occur. So then I'm going to go to my table where I have my activity series, and I'm going to look for zinc, and then I'm going to look for gold. I can see that zinc is above gold, so that tells us that my zinc can displace my gold. And so therefore, I'll have this. And then all I have to do is add my states. We know metals in their elemental state will be solid. We know that anything with a nitrate will be aqueous. And then finally, we just want to go through and make sure that we balance. And we can see that everything is balanced. Okay, here I have a ammonia reacting with water. I'm told I have a hint, I have one product. So basically I'm just going to combine all these together. And this is a reverse of a decomposition reaction that we talked about, where my ammonia and water will combine to form ammonium hydroxide. Okay, so here we have another possible single displacement reaction where silver and copper. So I'm going to go and look. As you can see, silver is here, copper is above it. Since copper is above silver, silver cannot displace copper. And so in this case, we're going to say no reaction. And so there would be no reaction to predict or products to predict. Okay, here we have another possible either synthesis or double displacement reaction. Again, it doesn't fit any of the molds that we know, but we do know that this is an acid because it starts with a proton or hydrogen. This contains a hydroxide, so that tells us it's a base. So as a result, we can see an acid plus a base. We can already predict that my product should be a salt plus water. And so this would be our neutralization reaction. So I know one of my products is going to be H2O, and then the other one would be Mn with NO3. And we can see here my valence on my manganese is 2, so therefore, okay, and anything with nitrate is aqueous, so I don't even need to look that up. And now we have to go through and we balance. I have 1 Mn, 1 Mn, 2 nitrates, 1 nitrate, so I'll put a 2 there. And then I have 4 hydrogens, 2 hydrogens, so I'll put a 2 there. And then outside of the nitrate, I have 2 oxygens, and I have 2 oxygens. So this would be balanced. Okay. So here I'm told that one of my products causes a burning splint to burst into flames, but I'm not told anything else about the other. Since I know one of them causes a glowing splint to burst into flames, we know this is our glowing splint test. And we know that our glowing splint test tests for oxygen. So I know one of my products is oxygen. Now I'm not told anything else. So I could say my other product is hydrogen, but as we talked about in class, my most likely other product would be water. And then we just have to ensure that we balance. Okay, and then the final reaction we're going to look at, silver with water. So we come to our activity series. We know, because we're going to remember, that my brakes are here, and anything above sodium, this will react with cold water, and anything above chromium will react with hot water. Silver is way down here. So since silver is below my regions which will act with water, I would say no reaction.